October 3rd, 2025. The object known as 3I Atlas made its closest recorded pass near Mars, a maneuver window that scientists had been tracking for months. But instead of the expected flood of high-resolution images and spectroscopic readings, something else happened. Silence. No official imagery, no publicly released telemetry, just a sudden and unexplained gap. In the absence of data, a different kind of signal emerged. Amateurs, independent analysts, and a growing number of astronomers began comparing the few available frames and emission reports. What they found didn't look like a typical comet. A CO2 jet pointing directly toward the sun, a nickel tetracarbonyl signature with no accompanying iron, a massive body moving with near-perfect gravitational compliance, showing none of the expected acceleration you'd expect from outgassing. And all of it unfolding on a trajectory so statistically rare it's hard to call it chance. Even more unsettling, claims began to surface of faint structured patterns in the nickel emissions, patterns that some describe as engineered geometry. And while those claims remain unverified, they sit uncomfortably beside a growing body of unaddressed anomalies. This is where the conversation turns, because when the data goes dark at a critical orbital moment, the silence itself becomes part of the story. And the people who've been following 3I Atlas for weeks know that what happens between now and early November may redefine everything we think we understand about what's moving through our solar system. For months, the October Mars flyby had been marked on calendars across observatories, research institutions, and amateur astronomy forums around the world. It wasn't just another pass. This was the moment when 3I Atlas would cross a position in space perfectly aligned for close observation. Mars-based assets, orbiters, and telescopes were ready. The geometry was precise, the timing carefully planned, and expectations were high. Scientists anticipated a cascade of sharp, high-contrast images revealing surface features, gas jets, thermal activity, and perhaps the first solid clues to explain why this object behaves so differently from anything seen before. But when the day came, nothing arrived. Not a single new image, not a single confirmed public data release, just silence. That silence felt heavy. It wasn't the quiet of normal data processing delays, which are usually brief and openly explained. This was something colder and more deliberate. The first hints came through official channels in short, carefully worded statements. They spoke of standard review timelines and routine verifications. But those who have followed these missions for years know how the process usually works. Preliminary frames are typically shared within hours or days. Spectral summaries appear in public logs. Orbital refinements are updated automatically. This time, everything stopped. It's the kind of silence that changes the atmosphere around an investigation. Researchers who had been preparing to analyze thermal emissions and dust behavior suddenly had nothing to work with. Observatories that had been coordinating their own follow-up schedules were left in the dark. Forums that normally buzzed with image breakdowns and comparisons turned into long threads of speculation. And underneath it all, a single question kept growing louder. Why would such a critical observation vanish into silence? The Mars flyby was more than just a visual opportunity. It offered a unique angle. Earth was beginning to lose line of sight as the object moved closer to the Sun, but from Mars, instruments could still capture clear, unobstructed readings. The event happened during a window in which the object's activity was expected to surge, a natural peak where jets intensify and surface heating reaches its most revealing point. If 3I Atlas carried any unusual structure, behavior, or artificial signature, this was the moment it was most likely to be exposed. The fact that this exact window coincided with the blackout is what set alarm bells ringing. Soon, independent observers began piecing together what little was left. Low-resolution ground-based observations showed small but noticeable irregularities in light curves. Spectral readings shared informally between amateur astronomers revealed odd signatures near the tail. These scraps weren't enough to build a complete picture, but they were enough to hint at something far from ordinary. The gaps became almost as meaningful as the data itself. Then came the subtle signs of institutional tightening. Several research teams quietly confirmed that their Mars-based observation proposals, approved months earlier, had been flagged for additional review without explanation. Data streams that normally update automatically paused. Archive pages displayed static dates, as though time itself had been frozen at the moment of closest approach. In some circles, the silence began to feel less like delay and more like containment. This moment matters because 3i Atlas is approaching a phase where every piece of information counts. Once it disappears behind the sun, there will be weeks of complete observational blackout. If something unusual happens during that time, it will go unseen. The Mars pass may have been the last clear chance to document its behaviour before this critical period, and that opportunity, for reasons no one will fully explain, has been allowed to vanish into silence. In the absence of images, analysts turned to the only remaining thread, the incomplete spectroscopic readings and scattered traces captured just before the blackout began. Buried inside those fragments was an emission fingerprint, one that doesn't fit neatly into any known natural comet model, one that raises more questions than it answers. This is where the investigation starts to take shape, not with what was shown, but with what wasn't. When the images failed to appear, attention shifted to what was left behind. Scattered across amateur databases, research mirrors, and observatory logs were narrow slices of spectral data captured in the final hours before the Mars flyby blackout. These were not complete datasets, but they were enough to paint an outline, a pattern buried in the frequencies of light reflected and emitted by 3i Atlas. And that pattern carried a signature that immediately set the scientific world on edge. Among the few clean readings, analysts noticed something that should not have been there: a strong nickel tetracarbonyl emission band. This is a compound almost never associated with natural cometary bodies. Its presence was not just unexpected, it was deeply anomalous. Natural outgassing typically reveals iron and nickel together, a balanced fingerprint shaped by the slow weathering of primordial material. But here, iron was strangely absent. The result was a clean, isolated nickel pattern, unlike any in the cometary record. What made this stranger was the consistency of the signal. Amateur astronomers, working with entirely different instruments across multiple continents, reported the same result within hours of one another. Independent labs attempted to disprove it, assuming instrumental error or calibration drift. But each attempt to smooth the signal failed. The nickel band remained where it shouldn't be, sharp and unmistakable. For those who followed interstellar objects before, nickel tetracarbonyl isn't just unusual. It's a marker of engineered environments on Earth, appearing in controlled industrial processes, not natural celestial ones. That fact alone doesn't prove anything, but it turns a cometary reading into a potential statement. It raises the possibility that what is being observed is not a random release of volatile material, but something structured, something designed. Some experts suggested exotic natural explanations, perhaps an unusual concentration of nickel-bearing compounds buried deep in the core, perhaps a surface layer enriched through processes we've never observed. Others were less convinced. They pointed to the lack of iron as a critical clue. In natural objects, iron is almost impossible to separate completely from nickel. They travel together in the dust grains forged in ancient stellar furnaces. To find one without the other isn't just rare. It demands a mechanism, one that no current comet model provides. And then came the second piece of the puzzle. The nickel emission wasn't uniform. Embedded within the signal were faint fluctuations, repeating in a subtle but measurable rhythm. Analysts disagreed on whether these were instrumental artifacts or structured modulations, but even the suggestion of regularity was enough to deepen the unease. If natural, it would imply an internal structure releasing gases in a stable, repeating pattern. If not natural, it could indicate something else entirely, a directed process. Meanwhile, the official silence continued. No confirmation, no denial, no technical briefings to clarify the readings, just quiet. In its place, forums and working groups began sharing their own spectral overlays, trying to decode what had been caught in those final moments before the flyby data disappeared. The independent community became the primary driver of the narrative, connecting dots that institutions refused to address publicly. This situation isn't without precedent. Throughout history, some anomalies have emerged not from official data releases, but from what slips through the cracks, small, overlooked signals that later prove to be the most important. What makes this moment different is how clean the signal is, and how well it aligns across different observation points. A single isolated reading can be dismissed. A repeating pattern across multiple observers is much harder to ignore. The implications are sharp. If the nickel signal holds, it would point to a form of material behaviour that challenges every assumption about how interstellar objects form and evolve. If it is something else, something deliberate, it would mark the first time in modern observation that a non-natural chemical pattern has been detected on an incoming deep space object. But the chemical fingerprint isn't the only irregularity. At the same time the nickel signature appeared, observers noticed something even stranger in the object's physical behaviour: a jet, narrow, stable, and aimed directly at the sun. In the quiet that followed the flyby, the strange chemical fingerprint wasn't the only clue. Long before the silence set in, a handful of observatories and experienced amateurs had been watching something else: a jet. Not a chaotic outburst of gas and dust like those that usually spray unpredictably from cometary surfaces, but a narrow focused stream aimed directly toward the sun. It held its shape, it held its direction, and it behaved more like a controlled exhaust than a natural plume. For anyone who has spent time studying comets, this was deeply abnormal. Natural jets are messy. They erupt from fractures and vents scattered across a body's surface, often changing orientation as the object rotates or as solar heating shifts. They bend, flare, and dissipate. They do not remain fixed on a single point in space for days. But in the case of 3I Atlas, the sunward jet didn't wander. It stayed locked on one axis. This detail might seem subtle, but it carries weight. A steady sunward jet implies either a stable surface vent perfectly aligned with the solar vector or something actively maintaining that orientation. The first possibility is extraordinarily unlikely. Objects tumbling through space tend to rotate on irregular axes, making sustained alignment almost impossible without some kind of internal control or external stabilizing effect. The second possibility, active orientation, raises questions no one is prepared to answer casually. What makes this more unsettling is the jet's composition. Early spectral readings showed it was dominated by carbon dioxide rather than water vapour, which is what most comets display as they approach the inner solar system. Carbon dioxide jets are not unheard of, but they are typically secondary, weaker, and short-lived. Here, the carbon dioxide signature was strong, clean, and persistent. Combined with the nickel tetracarbonyl detection, it created a picture of something operating far outside familiar patterns. During the Mars pass, observers who managed to capture low-resolution frames described the jet as unusually collimated. Instead of dispersing in a wide, diffuse spray, it formed a thin, almost lance-like structure. Even from a distance, it looked deliberate. Those who tracked it over several nights noticed that its brightness barely fluctuated, suggesting a steady release rate rather than the bursts typical of natural outgassing. Behind the scenes, several researchers began to whisper what many were already thinking. A sunward jet can function as a form of propulsion. By releasing material in the direction of the sun, a body can subtly adjust its orbit without producing the telltale signs of chemical burns or rapid acceleration. If such a system were controlled, it could allow an object to shift trajectory over long periods with incredible precision. That possibility, no matter how speculative, changes the conversation entirely. Institutions remained silent, but the data trails told their own story. Archived photometry hinted at microvariations that suggested the jet's output had been stable for a surprising length of time. No one knew how long it had been active, but its steadiness indicated that it was not a random event triggered by the Mars encounter. It had been there before, it was there during. And most troubling of all, it appeared to remain after. When these findings circulated, the community response split into two camps. One argued for a natural explanation, a rare but possible geological configuration, allowing a vent to remain aligned as the object rotated. The other pointed to the improbable stability and said it looked more like a deliberate behaviour than a geological accident. Both camps agreed on one thing: they had never seen a comet behave like this. And then came the question of alignment. The sunward jet was positioned almost perfectly along the solar vector. Its orientation suggested timing and geometry that were too clean to dismiss as chance. As one analyst put it, this isn't a random spray. This looks like a decision. With the jet and the nickel signature now forming a pattern, attention turned to the object's arrival path. If the chemical and physical behaviour is already strange, its geometry, the way it entered the solar system, makes the anomaly even harder to explain away. As the conversation around the chemical signature and the jet intensified, another layer of unease settled in. It wasn't just what 3i Atlas was doing now that disturbed researchers, it was how it got here. From the first tracking solutions, astronomers noticed something about its entry path that didn't fit the quiet randomness expected of a wandering interstellar object. Its arrival geometry was almost too clean. Most natural interstellar visitors arrive on sharply inclined, unpredictable angles relative to the plane of the solar system. They cut across like uninvited guests, wild trajectories born of deep space, gravitational slingshots, and ancient drift. But 3i Atlas slid in low, hugging the solar plane with an elegance that made seasoned orbital analysts pause. A low-inclination retrograde path is not impossible, but it's exceptionally rare. It places the object moving almost directly opposite the direction of the planets, but on a line so smooth it looked more like a planned insertion than a random intrusion. In practical terms, this geometry gave the object a strategic advantage. Its path made it easier to track near the ecliptic plane, but also made it difficult to observe once it moved closer to the Sun. Its route guaranteed that it would cross a natural observational blind spot, vanishing for a period during which it could change course without immediate detection. It was as if the trajectory had been chosen with awareness of how our telescopes work, slipping into a corridor where silence was guaranteed. The community began pulling historical records, comparing this path to other known interstellar objects. Even the most famous examples, chaotic and hard to predict, showed arrival angles that screamed of deep space randomness. But 3i Atlas wasn't chaotic. Its path was smooth, deliberate, predictable. Some saw this as a statistical oddity, the kind of rare coincidence that occasionally appears in large datasets. Others saw it as a deliberate approach vector, the kind you'd select if you wanted to minimize the odds of accidental detection during your most critical maneuver window. That's what made the Mars flyby so important. The geometry had positioned 3i Atlas for an almost theatrical pass, close enough to be scrutinized, perfectly timed before it would slip behind the Sun. And now, with the imagery missing and the emissions looking engineered, the trajectory no longer looked neutral. It looked calculated. What makes this more unnerving is how stable the approach remained over time. Tracking data showed no measurable non-gravitational deviations during the inbound leg. Normally, comets outgas unevenly as they warm, creating tiny but detectable nudges that gradually shift their orbits. 3i Atlas moved like a stone on rails, unaffected by the kind of irregular behavior most icy bodies display when crossing into the inner system. Researchers began to quietly ask questions they normally avoid. If the chemical signature hints at something deliberate, and the jet behaves like controlled exhaust, then what does it mean when the entire trajectory appears as if it had been planned long before the object ever came close to us? The geometry also carries a darker implication. A low inclination retrograde path is almost perfectly aligned to intersect key planetary orbits at predictable points. It's the kind of vector that maximizes opportunities for flybys and observation, but also for hiding in the sun's glare. The last time the astronomical community saw an object with such clean geometry, it became the subject of years of debate. This one, however, comes with more evidence stacked behind it. As these details circulated quietly between research groups, a shift began to occur. What started as scattered observations and speculative talk was slowly turning into a structured case file, a file that piece by piece painted a picture of something that shouldn't be random at all. And this leads to one of the most puzzling aspects of all. An object with mass this high, moving this cleanly, should be pushed and pulled in subtle ways. It should wobble even slightly under the effects of its own activity. But with 3i Atlas, it doesn't. Every object that moves through space tells a story through its motion. It can lie about its composition, it can conceal its structure, but it cannot fake its mass. The way it drifts, accelerates, and responds to solar heating reveals the hidden forces at work inside and around it. When astronomers began to carefully study how 3i Atlas moved, they expected to find the faint irregularities typical of active comets. But the readings told a different story, a strangely quiet one. From the moment it crossed the outer solar system, 3i Atlas behaved with an almost unnerving precision. No measurable deviations, no drift, no gradual shifts that could be traced to uneven outgassing. For a body displaying a sunward jet and persistent activity, this made no sense. Any natural comet venting gas would experience subtle, constant tugs. Those tugs may be small, but over long distances they build up, gently altering the object's path. Here, nothing of the sort appeared. It was as though the object was ignoring the physics of its own activity. This is where things became uncomfortable for mission planners and orbital analysts. Initial calculations placed 3I Atlas in a category far more massive than most visiting interstellar bodies. Observations of its brightness, the stability of its trajectory, and the absence of any visible acceleration all pointed in the same direction. An object with an extraordinary amount of inertia. It wasn't a lightweight traveller being nudged around by its environment. It moved more like something built to hold its line no matter what. Some researchers tried to explain this away with natural mechanisms. Perhaps the sunward jet was counterbalanced by other hidden vents on the opposite side. Perhaps the mass was simply larger than initial estimates, giving it the momentum to ignore subtle outgassing forces. But these explanations started to collapse under their own weight. To remain that stable for this long would require a balance that is so precise, so delicately maintained, that it borders on the impossible for a naturally tumbling object. This is where independent analysts stepped in. Using publicly available tracking data, they overlaid the trajectory against standard comet models. The deviations expected under even modest venting never appeared. The line remained clean, straight, unyielding, and this behaviour didn't just start near Mars. It had been that way since the first detections on its inbound path. From the edge of the system to its current position, it has behaved less like a body-losing material and more like a vessel with complete control over its momentum. This realization sent ripples through the community because it forced a simple, unsettling question. If this object is venting material toward the sun, where is the recoil? Where is the trace of that push? Every natural jet acts like a gentle thruster, leaving fingerprints in the object's orbit. But 3I Atlas shows none. Some tried to reconcile this with exotic physical structures, a configuration so symmetrical that opposing forces cancel each other perfectly. But again, nature rarely engineers such perfection, and the more data analysts compiled, the clearer the line became. This was not the movement of a fragile, erratic comet. This was the glide of something that either possesses immense mass or has the ability to adjust its course with remarkable subtlety. Behind closed doors, this is where institutional caution started to harden. An object with this kind of behaviour changes the stakes. It doesn't just challenge the idea of a typical interstellar visitor. It pushes the conversation into territory no one wants to enter too early. Official channels stayed silent, but leaked internal notes described the orbit as highly resistant to perturbation, a phrase rarely applied to small bodies. This stability, combined with the jet and the nickel emission, forms a pattern that can no longer be dismissed as a string of coincidences. It suggests intention or extraordinary structure, either outcome unlike anything routinely observed. But the mass problem is only part of the picture. As analysts dug deeper, they found yet another anomaly hiding in plain sight. The object's heat behaviour refuses to follow the patterns expected of icy bodies approaching the inner system. Its surface is warming, but not the way it should. For every comet entering the inner solar system, its thermal profile tells a predictable story. As sunlight intensifies, the surface warms, frozen volatiles begin to sublimate, and jets emerge in response to that heating. Temperatures rise steadily and follow the object's changing distance from the sun like clockwork. But when scientists began examining the thermal readings collected from 3I Atlas, that rhythm was broken. The first warning signs came from early infrared observations. Instead of heating at the expected rate, 3I Atlas maintained a strangely steady thermal signature, almost as if something was buffering or controlling the way its surface absorbed energy. Even as the object drew closer to the sun, its temperature curve remained oddly flat. It wasn't cold, but it was stable. Too stable. In natural comets, even minor surface changes trigger spikes, dips, and unpredictable bursts of heat as new material is exposed. 3I Atlas did none of that. As more data trickled in, the picture grew stranger. When jets are active, their behaviour usually matches the heating cycle. More sunlight means more sublimation and more thermal variation. But here, the sunward jet appeared almost independent of the heating profile. It remained steady, unaffected by the fluctuations that should have been driving it. To some, it felt as though the jet was being controlled rather than triggered by temperature. To others, it looked like the surface was layered or shielded in a way that limited how much heat actually reached volatile material beneath. Some researchers proposed a natural explanation involving an unusually thick crust. If the outer shell of the object is dense enough, it could delay heating, slowing the response to sunlight. But this alone doesn't account for the regularity. Thick crusts still fracture, and when they do, they produce bursts of energy that show up clearly in thermal profiles. 3. I-Atlas displayed none of those chaotic bursts. Its thermal signal flowed like a straight line. Others whispered about something more deliberate. A structure designed to regulate heat would produce exactly this kind of smooth signature, absorbing, redistributing, or reflecting energy in ways that prevent sudden spikes. If this were the case, the jet wouldn't be responding to temperature at all. It would be following an internal command or some underlying mechanism, not the sun's influence. Infrared specialists began combing through the scattered readings from ground-based observatories. Even through atmospheric interference, a pattern emerged. 3I Atlas seemed to maintain a controlled thermal envelope around its surface. The heating rate lagged behind the solar input, almost as if it had been engineered to resist rapid change. The result was a kind of eerie thermal calm, a sharp contrast to the wild, unpredictable heating behavior seen in typical icy bodies. The significance of this is easy to miss but hard to ignore. Thermal behavior is often one of the most reliable tools for distinguishing between natural and engineered structures in space. A comet doesn't manage its temperature, it endures it. 3I Atlas seemed to be doing the opposite. It behaved less like a rock reacting to sunlight, and more like something regulating its own skin. This finding added pressure to those already unsettled by the missing Mars imagery, the nickel emission, the jet, and the clean trajectory. Each anomaly alone might have been explained away. Together they were forming something different, a structured pattern, a network of signals pointing toward control rather than chance. As thermal analysts quietly circulated their reports, another layer of this mystery emerged. The emissions tied to the nickel signature weren't scattered or chaotic either. They were organized. Observers began to notice faint but repeating geometric patterns in the way the nickel plume expanded through space. Not random turbulence, not messy outgassing, geometry. In the early hours after the Mars flyby blackout, a few patient observers kept scanning the scattered emission data. What they began to notice wasn't obvious at first. It wasn't a spike or a flare or anything that screamed for attention. It was a shape, quiet, persistent, hiding beneath the noise, a geometric echo. When nickel tetracarbonyl is released naturally from a cometary surface, the resulting plume behaves like a cloud caught in the wind. It spreads chaotically, it twists and frays, shaped by random fractures, solar wind, and internal turbulence. But the nickel emission traced around 3I Atlas refused to act like a cloud. Instead, it outlined repeating structures, thin arcs and angular lines that reappeared night after night, always in the same orientation relative to the body. This caught the eye of independent analysts, who began overlaying the scattered data. Each observer had recorded only a small piece of the plume, but when those fragments were stitched together, the pattern became undeniable. The nickel plume wasn't expanding like vapor, it was forming something closer to a lattice, narrow streams branching outward, crossing at consistent intervals as though guided by invisible architecture. At first, the reaction was disbelief. Most of the community assumed it was a processing artifact, a trick of alignment caused by different instruments merging their readings. But when teams began reprocessing their data independently, the same pattern emerged. It wasn't just repeating, it was persistent. This was not the first time an interstellar object displayed strange behavior, but it was the first time analysts were looking at something that behaved as if its emissions were organized. In natural bodies, plumes appear in random clusters. They don't follow straight lines. They don't hold fixed angular spacing over multiple observation periods. They don't move like something engineered. The pattern echoed with unsettling precision. Some compared it to the ribbing of a structured frame, others to the alignment grids used in satellite heat dispersal systems. There were no images clear enough to confirm its source, but the emission geometry alone suggested either a hidden internal structure or a controlled venting process, unlike anything recorded before. Official channels offered nothing in response, no statements, no clarifications, not even the usual cautious language about instrument uncertainty. And that silence by this point had become part of the story. When anomalies pile up, institutional silence begins to sound like an answer of its own. Behind the scenes, analysts split into camps. One side insisted that some extreme geological structure could, in theory, create a repeating venting pattern. Perhaps fractures frozen into the body long ago, now reactivated by solar heating. The other side argued that natural fractures would not maintain geometric spacing over time. They would shift, distort, or break down as the body rotated and heated unevenly. 3i Atlas didn't. Its emissions stayed locked in place as if anchored to something solid beneath the surface. What made this more unnerving was how the pattern behaved relative to the jet. The sunward CO2 jet remained fixed, while the nickel emission fanned out in quiet, repeating structures around it. The two didn't interfere with one another. It looked coordinated, almost designed. A few specialists began whispering a phrase they had been careful to avoid until now: structural coherence. In natural objects, everything is noisy. In engineered systems, patterns hold. If this object's emissions are structured, then someone, or something, built it to be seen this way. A beacon, not a rock. And then came another quiet realization. The angular structure of the nickel emission lined up with a historical coordinate, a direction in deep space already infamous for its own unresolved mystery. A place tied to one of the most haunting unanswered signals ever recorded. When the structured pattern in the nickel emission became clear, analysts began to look outward, beyond the plume, beyond the trajectory, beyond the object itself. It was one thing for a comet to act strangely. It was another for its behaviour to line up with something that had already haunted deep space research for decades. One of the more patient observers, working from old signal archives, noticed something uncanny. The angular structure of the nickel plume, once mapped onto celestial coordinates, was pointing toward a region in deep space, tied to one of the most famous unanswered detections in radio astronomy. The direction from which a narrowband radio burst was once recorded in the late 70s. A signal that has never been fully explained, only remembered. The alignment wasn't perfect, but it was close enough to rattle anyone who knew the history. This was the same general region associated with that unexplained moment when radio telescopes caught a sharp, isolated transmission. It had always been treated as an enigma, too clean to be random noise, too brief to be verified, too strange to be forgotten. And now, nearly half a century later, an interstellar object was carving a geometric plume in the sky that seemed to echo that same corridor of space. The discovery began quietly, with cautious emails and encrypted message threads between independent analysts. Nobody wanted to be the first to say it aloud, but the longer the alignment held up under scrutiny, the more difficult it became to ignore. This was no vague similarity. The nickel plume, with its repeating lattice, was tilted along an axis that matched the historical pointing data. To some, it was coincidence. To others, it was choreography. The implications were unsettling. If the plume's geometry was deliberate, then pointing it toward that direction could mean it was broadcasting, or at least aligning toward something specific. This idea wasn't new. Some theories have long proposed that any technologically engineered interstellar object wouldn't need to transmit in radio frequencies at all. Its physical structure, its emissions, even the way it reflected light could itself carry encoded information. A message, not in sound, but in shape. Several astronomers began quietly reviewing the old signal archives, searching for subtle correlations between the original direction and the current trajectory of 3i Atlas. What they found didn't prove anything, but it deepened the unease. The object's entry path seemed optimized to cross the solar system in a way that aligned it with this old point in the sky before perihelion, as if it were retracing a line already drawn. Others went further, speculating that the nickel plume wasn't just geometry, it was orientation. A slow, deliberate gesture toward a region that might matter to whatever this object truly is. The sunward jet stabilized the body, the trajectory ensured a clean approach, and the plume, carefully aligned, pointed back towards something ancient in our records. The idea was polarizing. Some dismissed it outright, insisting that any connection between the old signal and this object was purely symbolic, a human attempt to force meaning onto coincidence. But others saw the weight of stacked anomalies and began to wonder if the object had been seen, in a way, long before it was ever visible. The geometry itself carried another strange quality. It wasn't just directional, it appeared to hold angular symmetry. the plume's structure repeated in mirrored arcs, like a marker designed to be recognized from multiple angles. If it was meant to be seen, it was designed with precision, and if it was designed with precision, then the alignment with that particular patch of sky was not an accident at all. This realization changed the mood in research circles. Until this point, the anomalies could still be discussed as bizarre natural phenomena, unusual but explainable. But now the conversation had shifted into territory no institution wants to walk into without absolute proof. If this object is intentionally oriented, then someone built it. And if someone built it, the question isn't just what it's doing here, it's what it's pointing to. With the perihelion blackout approaching, this alignment carried a chilling consequence. Whatever was meant to happen could unfold when the object is hidden behind the sun, when the world's telescopes will be effectively blind. A silence almost perfectly timed to mask a maneuver or a signal event. A silence that feels less and less like coincidence with each passing day. And just as the nickel plume pointed outward, something else happened closer to home. Faint, conflicting reports began to emerge from near Mars. Observers described brief, unverified glints, shadows, movements, as if something had stirred near the object in the hours after it passed beyond our clear line of sight. In the days following the Mars flyby blackout, scattered reports began to surface from observers who hadn't yet turned their instruments away. They weren't the large institutions, not the flagship telescopes, but smaller teams, university research groups, independent astronomers, deep sky trackers, the kind of observers who work in the quiet margins of space monitoring. They described something faint, fragmented and easy to miss. Glints, brief fluctuations in brightness, shallow, shifting shadows against the black. None of these reports came through official channels. They emerged in private forums, encrypted message boards, late-night emails between people who knew what they were risking by even mentioning it. At first, the claims were easy to dismiss. Mars is a noisy region for optical work. Reflected sunlight, instrument drift and atmospheric interference can play tricks on even the most disciplined eyes. But this was different. The reports were consistent. The timing matched. And most unnervingly, they came from multiple points of observation across different continents. What they described was a dim but regular flicker near the path of 3I Atlas, shortly after its closest approach to Mars. The object itself was already slipping out of direct view, caught in the narrowing corridor between Mars and the Sun. It should have been quiet, invisible, and unreachable. Instead, something was moving. These reports didn't speak of bright flares or dramatic changes, nothing that would trigger public alerts. The shadows were subtle. One observer described them as like a shimmer behind glass. Another said it was as if something was adjusting its position just beyond the threshold of clarity. There was no single light source. It wasn't an explosive burst. It was movement, controlled, measured, purposeful. Several amateur teams ran back through their archived frames from the flyby window. When they increased contrast and stacked the exposures, the faint signatures became clearer. A small localized pattern of shifting brightness offset slightly from the main object. Too steady to be a processing error, too precise to be cosmic noise. These shifts hinted at something in motion around the object, or perhaps something detaching from it. The idea of a secondary structure emerged quietly. A few analysts speculated that what had been observed wasn't the core of 3I Atlas itself, but something moving near it. Whether debris, a fragment, or something far less natural, no one could say. But the pattern didn't behave like random debris. It followed a shallow arc, remained near the object for several hours, and then faded into the solar glare. Institutional silence deepened the unease. If any of the Mars orbiters had caught clear readings, nothing was shared. No thermal flashes, no spectral spikes, no movement alerts. Just the same rehearsed line about data being under review. But by now the silence had worn thin. Analysts understood what under review often meant. It meant something was being held back, something significant enough to manage rather than simply release. Some within the independent community began to compare the shadow patterns to known signatures of artificial satellite deployment. Slow, controlled separations with minimal plume or light scatter. Others warned against leaping to conclusions, reminding everyone that this could still be natural fragmentation. But even those who urged caution admitted one thing. If this was a natural break, it was the most orderly and quiet one they had ever seen. This possibility opened a new line of speculation. If 3I Atlas carried structure, could what observers saw near Mars have been a controlled release, a probe, a secondary unit, a component designed to remain unnoticed during its main trajectory? The thought lingered like smoke. It was impossible to prove, but impossible to ignore. As these whispers spread through private research circles, the official timeline became clear. After the Mars pass, 3I Atlas was heading toward the Sunday, approaching the blackout period. This meant that anything happening in those weeks could unfold entirely unseen. No major observatory on Earth would have a clean line of sight until it re-emerged on the other side. And whatever moved in that shadow over Mars, whether fragment or something else, would be gone, slipping behind the curtain. This moment marked a quiet turning point in the conversation. Until now, the debate had revolved around what 3I Atlas was. But after Mars, the question became what it was carrying. And if something was released into that orbital corridor, it would move silently through the blind spot, unseen by nearly everyone. And then, just as these reports began to spread, another voice entered the debate. One that had been there from the beginning, now speaking with sharper urgency. A scientist who has never shied away from unpopular questions, and whose words tend to echo far beyond academic circles. In the weeks after the Mars flyby blackout, the silence from official agencies had hardened into something almost ritual. No images, no reports, no briefings. It was as if the world's most anomalous interstellar object had simply been folded into a quiet bureaucratic void. But not everyone remained silent. One voice broke through that stillness, calm, precise, and unsettlingly direct. It belonged to a scientist whose name has become inseparable from the story of interstellar mysteries, Avi Loeb. He had been following 3I Atlas from the start, well before its Mars pass, well before the public began to sense that something was wrong. In interviews, essays, and private conversations, he had been careful with his words, but he never softened them. From the earliest emission reports, Loeb pointed to the mounting irregularities, the clean trajectory, the absence of non-gravitational drift, the jet that seemed too steady, the nickel signature that looked engineered, and now the silence at the exact moment when the object should have been most visible. When Loeb spoke after the Mars blackout, his language was sharper. He didn't make dramatic claims. He didn't lean into speculation. He simply pointed out what the data no longer allowed anyone to deny. "We're watching an object behave as if it was designed not to be accidental," he said in one of his early remarks. It wasn't a conclusion. It was a warning. He framed his argument the way he always does, through patterns. A comet with this kind of thermal stability, trajectory precision, and organized emission geometry does not fit comfortably within known natural models. Each of these features could, in isolation, be explained away with creative physics. But together, they stack. And when patterns stack this cleanly, they point to something with intention. What unsettled many wasn't just what he said, but how he said it. Loeb was measured, unshaken. If something is engineered to be detectable, he remarked, it won't announce itself in a single obvious gesture. It will leave a trail of signals meant only to be understood by civilizations capable of noticing. It was a quiet challenge to the entire astronomical establishment. A statement that if this is what it seems to be, ignoring it would be a choice, not an accident. But Loeb also pointed out something else. If 3I Atlas were to make any course adjustment or maneuver, the best moment to do so would be during the perihelion blackout. A period when the sun's glare swallows everything, when the world's best instruments fall silent. An invisible window, built into the object's path from the beginning. If it changes course, then no one will see it happen in real time. We'll only find out after the fact, when it re-emerges on a new trajectory. His statements landed like a shockwave across research groups. Some dismissed him, as they often have, accusing him of leaning too easily into the extraordinary, but others listened more closely this time. The data supported too many of his points. His warnings about maneuver windows weren't theories, they were orbital facts, and his quiet insistence that the object may not be passive but active gave shape to what many had only whispered about. What also disturbed some was his subtle nod to what might happen next. Loeb didn't talk about direct contact or alien technology. Instead, he pointed to something more pragmatic. If 3I Atlas demonstrates a deliberate course change after perihelion, the conversation will no longer belong to astronomers alone. it will become geopolitical, economic, strategic. If the behavior is artificial, he said, it will not only reshape science, it will reshape everything built on the idea that we are alone. Behind closed doors, others echoed his concerns. If this object is more than natural debris, the consequences are not purely academic. The stability, the emissions, the trajectory, they suggest not just detection but design, and design implies a message, whether intended or not. By now, Loeb's warning had begun to ripple far beyond astronomy circles. Quiet discussions had already started among governments, think tanks and economic analysts, not because they understood what the object was, but because they understood what a confirmed artificial origin would do to markets, infrastructure, and the fragile idea of normalcy that underpins the world. When Avi Loeb's warning spread beyond the scientific community, it didn't just spark curiosity. It triggered something far more immediate and far less academic: fear. Not the kind that shouts, but the quiet, calculated kind that moves through financial systems, boardrooms, and closed-door meetings long before the public feels the tremor. What was once an astronomical mystery had begun to cast a shadow over global markets. It started with subtle movements. Analysts who track real-time fluctuations in commodities and strategic assets noticed something unusual. Gold futures began to edge upward. Certain energy markets grew tense. Long-term investments in orbital infrastructure and deep space ventures were quietly put on hold. It wasn't a crash. It was a soft tightening, the kind that happens when those who can see a storm don't scream. They prepare. The reason was simple. If 3I Atlas is what Loeb suggests, a deliberately detectable object, possibly capable of maneuvering, the implications stretch far beyond science. Any acknowledgement of non-natural origin would shift the world overnight. Governments would need to respond. Strategic postures would change. National security frameworks built on a purely human-centric understanding of the skies would crack. In a moment like that, information becomes a form of power and uncertainty becomes currency. In certain circles, whispers grew louder. Insurers began quietly reassessing risk models for satellite constellations and long-range communications networks. Intelligence agencies reportedly pushed for closed technical briefings with astronomical observatories. Several major financial monitoring groups detected a surge in high-volume trades related to defense technology and aerospace infrastructure. The world wasn't panicking yet, it was bracing. Part of the tension came from the blackout window itself. If a course change happens during the perihelion silence, no one will be able to respond in real time. By the time the object re-emerges, the reality may have already shifted, and that uncertainty is poison to global markets. It's not the maneuver itself that causes instability, it's the unknown. The first sharp reaction came when several think tanks began floating contingency models in private. These models didn't predict alien contact in cinematic terms. They focused on ripple effects, disrupted trust in satellite surveillance, shifts in global military posturing, legal chaos over orbital jurisdiction, and mass capital flight from unstable sectors. A single confirmed maneuver could send waves through everything from energy trading to shipping routes. At the same time, a smaller but louder current of speculation began to build in public. Markets thrive on rumour as much as fact. Independent analysts began to publish their own reports, linking the blackout period to potential strategic disclosures. Some claimed governments already knew more than they were admitting. Others argued that the silence itself was an indicator of preparation behind closed doors. But beneath all the noise, something else was becoming clear. For decades, humanity has imagined how the world might react to an unmistakable sign of non-human intelligence. The common image is of chaos, disbelief, and awe. The reality, however, looks different. It looks like quiet meetings, shifting investments, unspoken calculations about who gets to control the story when it breaks. This is where the scientific mystery collides with power. If 3I Atlas shows controlled movement, it won't belong to astronomers anymore. It will become a matter for states, defense networks, corporations, and markets. It will be claimed, contained, interpreted, and possibly weaponized. And while the world waits in silence, a different force is already moving beneath the surface. The people who won't wait for official narratives. Amateur analysts, independent researchers, and quiet technical communities are already combing through every scrap of leaked data, every frame, every archived spectral trace. They refused to let the story be decided in boardrooms. This movement, disorganized, persistent, and fiercely independent, is starting to push against the blackout. They have no official voice, no institutional weight, but they have reach, and they're beginning to reassemble the pieces. While governments and institutions tighten their grip on information, a different current began to surge below the surface. It didn't move with the caution of official statements or the patience of bureaucracies. It moved fast, unpredictable, and global. The independent research community, amateurs, rogue analysts, citizen astronomers, and quiet professionals working outside their institutional roles, had reached a breaking point. If the blackout wasn't going to end from the top down, they would pierce it from the bottom up. This movement didn't begin with a single group or leader. It began with frustration. The Mars flyby should have been the clearest moment of observation in the entire trajectory. Instead, all they received were canned statements, redacted timetables, and data that simply never arrived. For many of these independent observers, this wasn't just about science anymore. It was about ownership of the truth. They began pooling their resources. Amateur observatories across multiple continents synced their equipment to watch the object's projected re-emergence corridor. Software developers built shared data archives where even the faintest fragments of spectral readings and optical traces could be uploaded and cross-checked in real time. Every tiny detail, every wisp of emission, every flash near Mars, every telemetry echo was treated like a clue in a vast, unsolved puzzle. What made this pushback powerful wasn't the size of any single team, but their ability to coordinate. No central command, no official funding, just thousands of eyes and instruments networked together. In a way, this collective became a mirror image of the object itself, quiet, precise, organized. And unlike the institutions, they weren't bound by the same diplomatic silence. The first breakthrough came from a small observatory in South America. They had captured several faint light curves during the final hours before 3i Atlas slipped into solar glare. When they uploaded the data to the shared archive, another group in Eastern Europe overlaid it with their own spectral traces. The alignment was eerie. Buried beneath the noise was a faint but repeating signal, small pulses in the nickel emission pattern, too regular to be dismissed. It wasn't enough to call it a transmission, but it was enough to prove that something was still happening during the blackout period. As the news spread through the community, new contributors joined the effort. Radio astronomers reactivated dishes usually reserved for educational work. Students built software to align low-quality frames into composite images. An old deep sky station in the Canary Islands even began feeding raw telemetry to the network in real time. For the first time since the Mars silence began, the narrative was shifting away from those who held the data to those willing to dig for it themselves. And with this shift came a different kind of tone. Unlike the polished language of official agencies, the community spoke plainly. They didn't couch their findings in carefully crafted uncertainty. They talked about repeating geometry, stable emissions, and controlled silence. They pointed at the perihelion blackout and called it what they believed it to be, a maneuver window. Not everyone in the community agreed on what 3i Atlas was. Some were convinced it was a rare natural body behaving in ways we didn't yet understand. Others believed it was something built, an engineered object, left for us to notice. But they all agreed on one point. Silence was no longer an option. The pressure grew as independent findings spread online. Data visualizations showing the lattice structure of the nickel plume circulated through encrypted groups and eventually leaked into public platforms. Amateur radio groups posted time-stamped logs of unusual background fluctuations near the object's path. Even pilots flying near the Terminator line reported seeing brief, unexplained flashes from the direction of the sun. The pushback began to erode the quiet wall built by institutions. Officials could control press releases and orbital data streams, but they couldn't control the sky. People were pointing their instruments anyway. The blackout no longer belonged entirely to governments, and as the reassembled data began to paint a clearer picture, the timing of everything, its path, its jet, its emission geometry, its behavior near Mars, started to align toward a single point in time, a window where everything would either confirm or collapse. That moment wasn't months away, it was days away. The blackout would soon give way to re-emergence, and if something changed during that silence, the orbit itself would tell the truth, whether anyone wanted it to or not. The re-emergence corridor was approaching. In the halls of power, in universities and small observatories scattered across the world, everyone watching 3i Atlas understood what this meant. This was the point everything had been leading toward, the perihelion blackout. That carefully aligned stretch of days where the object would be swallowed by the sun's glare, unreachable to most instruments, untraceable by ordinary eyes. If something was going to happen, it would happen here. This wasn't a casual blind spot. It was built into the geometry of the orbit itself. As the object slipped behind the sun, the vast majority of Earth's tracking network became effectively blind. Ground-based telescopes fell silent. Infrared surveys lost their lock. Even the most advanced orbital platforms struggled to maintain a clear line of sight. For a natural comet, this would be routine. For an object with this history, this precision, and this pattern of behaviour, it felt like the closing of a curtain before an act the audience wasn't meant to see. In the weeks leading up to this moment, every anomaly had been pointing toward this window. The steady CO2 jet, the nickel emission lattice, the low inclination retrograde path, the mass stability, the missing Mars imagery, the reported shadow movements. All of it, intentionally or not, created the conditions for something to occur when no one could directly watch. It was the kind of orbital alignment that doesn't just happen, it's leveraged. Inside closed briefings, quiet questions began to surface. If this is a natural object, why does its behaviour seem to concentrate around this exact period of invisibility? If it isn't natural, what kind of event could unfold in the blind? A course adjustment, a controlled deceleration, a hidden deployment, or something none of the existing models could even describe. Publicly, agencies maintained their practiced silence. Official statements spoke of the routine challenges of observing objects during perihelion. Nothing unusual, nothing alarming. But behind those words, the tension was visible in the sudden tightening of observation schedules, in the surge of private tracking efforts, in the hurried coordination between networks that normally compete rather than cooperate. Even the smallest changes in trajectory after re-emergence would be enough to confirm what everyone feared. Meanwhile, the independent community was fully mobilized. Small observatories across Africa, South America, and the Mediterranean were preparing for the first moment the object would break free from solar glare. They couldn't see what happened in the blackout, but they could catch its shadow on the other side. Every spectrograph, every camera, every dish was synchronized to those first precious minutes after reappearance. If 3i Atlas was going to reveal its true nature, it wouldn't be in the middle of the blackout. It would be in the orbit it carried afterward. The waiting felt like a held breath. Analysts who'd spent months studying the object stopped arguing about what it was and focused entirely on what would happen. If the trajectory remained perfectly consistent, the case for a natural explanation, however strange, would hold a little longer. But if it reappeared off course, even by the smallest fraction, it would be the moment the narrative shifted permanently. Some whispered of older scenarios, plans drawn up quietly by strategic agencies decades ago. What happens if something non-human demonstrates technological capability in our solar system? Those plans were never meant to be public, but fragments of them had leaked over the years, and they painted a picture not of open discovery but of control. Others within the independent network spoke of something entirely different. What it would mean if the object didn't simply adjust its course, but lingered. If it slowed. If it acted like something that had arrived, not something just passing through. In the final hours before perihelion, everything seemed to slow down. Every feed, every analysis thread, every encrypted chat. A kind of planetary silence fell, not the institutional kind, but something heavier. Everyone watching knew this was not just another moment in an orbital timeline. It was the moment where the story could either fracture into myth or become history. And in that silence, a single question began to echo between those who had been watching from the beginning. If 3i Atlas maneuvers here, how long have we really been its audience? In the hours leading into the blackout, the conversation shifted from observation to interpretation. The question was no longer what if something happens during perihelion. It was why this object behaves as if the blackout was always the plan. The thought was quiet, uncomfortable, and deliberate. If everything about 3i Atlas, from its geometry to its emissions, seems designed to exploit this moment of invisibility, then maybe it isn't a comet at all. Maybe it's something meant to be seen just enough to be noticed, and then to disappear at the most critical point. The probe hypothesis didn't emerge out of nowhere. It had been lurking at the edges of the conversation for months. It was whispered in private messages, buried in anonymous data analyses, passed between small circles of researchers who had grown tired of pretending the pattern didn't look intentional. The idea was simple. If an advanced civilization wanted to survey or signal other star systems without direct communication, it wouldn't beam out messages. It would send something physical, something that carries its own data, something designed to arrive looking almost natural until the moment it doesn't. The behaviour of 3i Atlas fits too cleanly into that framework. Its low-inclination retrograde trajectory would minimise detection during the approach, slipping beneath the clutter of solar system traffic. The sunward jet could be more than an exhaust. It could be a stabilisation system, allowing the object to maintain orientation with surgical precision. The nickel tetracarbonyl plume, structured into repeating angles, may not be a random emission at all, but a visual marker, a kind of passive broadcast written not in language, but in geometry. The thermal stability adds another layer. If the object is regulating its surface temperature, it suggests shielding or engineered material, something capable of absorbing and redistributing energy far more efficiently than ice and dust. And the total absence of non-gravitational acceleration, despite continuous jet activity, looks less like coincidence and more like control. Every element points away from chaos and toward precision. Within the independent research community, discussions grew more focused, almost clinical. If this is a probe, what kind of probe is it? Some envisioned something inert, a silent recorder drifting between star systems, designed to activate only when it encounters a technological civilization capable of recognizing the anomalies for what they are. Others speculated about a more active purpose, something capable of maneuvering, transmitting, or even deploying smaller systems during periods of guaranteed observational blindness, like the Mars Shadow event. Those who were more cautious reminded everyone that extraordinary behavior does not always mean deliberate design, but even they admitted that the stack of coincidences had grown too tall. If this is natural, one analyst said, then it's the most cooperative natural object in recorded history. The probe hypothesis also explains something more subtle, its silence. No detectable narrowband transmissions, no direct contact, no obvious energy signatures. If it were designed to be found, it wouldn't speak to us in the way we expect. It would leave a trail, a breadcrumb path for civilizations advanced enough to recognize structure in the noise. In that light, the object's anomalies are not bugs, they're instructions. And then there's the Mars window. If something detached or moved around the object during that moment, it might not have been random debris. It could have been a payload release, a smaller unit designed to remain in our system, while the primary object continues its trajectory. A hand extended and then withdrawn before anyone could grab hold. The more analysts examined the timing, the clearer it seemed. The arrival path, the flyby silence, the emission geometry, the maneuver window, each piece fits too neatly, like steps in a choreography designed long before we ever noticed. If this is a probe, it's not improvising, it's following a script. This idea spread far beyond scientific circles. Intelligence analysts, policy strategists, and even cultural theorists began quietly briefing one another on what such a revelation would mean. A probe does not require a reply, it requires recognition, and once it's recognized, the burden of meaning shifts entirely onto us. But the hypothesis comes with a chilling corollary. If it is a probe, then it didn't just appear out of nowhere, it was sent. And what's more unsettling than its presence is its precision, its ability to arrive, act, and conceal itself exactly where human eyes are weakest. The re-emergence corridor is only days away. If a maneuver is detected, the probe hypothesis will no longer live in quiet speculation. It will surge into the open, dragging everything with it: science, politics, belief. A single orbital deviation would be enough to turn whispers into a new reality. And yet, beneath all this calculation, another thought lingers. If this object was meant to be seen, if the trail of anomalies is intentional, then it's not just about its movement, it's about us, who we are when we finally realize we're not alone. The final hours before the re-emergence of 3i Atlas didn't feel like the build-up to an astronomical event. It felt like a world holding its breath. In control rooms, in small observatories, in government monitoring facilities that do not officially exist, there was a quiet, heavy stillness. The object was still hidden behind the sun. No telescope could pierce that glare. No sensor could track it cleanly. Nothing was visible, and yet everyone watching knew that this was the line, before and after, silence and revelation. For months the story had unfolded piece by piece. The nickel emission lattice, the sunward jet, the stable trajectory, the Mars shadow, the blackout. Every anomaly had built toward this moment, a single stretch of time when the object could change its path, adjust its behaviour, or simply continue on its way. But whatever happened here, unseen, would shape the entire narrative when it reappeared. Inside official circles, the stakes had shifted. This was no longer about science alone. If the object emerged exactly where the models predicted, the world would breathe easier. An extraordinary but natural event could be folded back into scientific debate, debated quietly for years to come. But if it came out of the blackout even slightly off course, nothing would stay quiet. One maneuver would mean intention would mean design, and design would mean that someone, or something, had crossed into our star system on purpose. The weight of that possibility was already being felt long before any observation was made. Defense networks were on quiet standby. Financial markets were preparing for shocks. Space agencies were bracing for questions they may not be able to answer. And among independent analysts, there was an almost reverent kind of silence, like standing on the edge of a threshold they had spent their entire lives trying to imagine. For the amateur observers, the ones who had never accepted institutional silence, this was the night they had prepared for. Telescopes across the world were synchronized to a narrow corridor of sky, where the object was expected to break free from the sun's glare. They wouldn't get the first look. That honor belonged to the orbital arrays positioned in deep space, but they would get the first public look, the kind that can't be buried in clearance levels or delayed behind classified channels. The re-emergence isn't just about position, it's about behavior. If the object emerges on its original trajectory, it remains a mystery, strange, unsettling, but distant. If it emerges on a new course, the probe hypothesis stops being a theory whispered in late-night analysis threads and becomes a fact the world has to face. And if it slows down, or lingers, it would be more than confirmation. It would be contact without a voice, a silent arrival. For those who had followed the story from the beginning, it was hard to ignore how meticulously the sequence had unfolded. Its trajectory had brought it through the plane of the solar system with unnerving precision. Its emission geometry pointed toward a direction tied to an unsolved signal from the past. Its behavior near Mars hinted at something separating or activating, and its vanishing into perihelion was timed with near-perfect understanding of how blind we become when the sun swallows the sky. Whether by coincidence or by design, everything led to this, a single, quiet threshold. In the final hours, data terminals across the world fell into a strange rhythm, waiting, refreshing, watching nothing. It felt like the moments before an eclipse, when the world holds still, like the pause between two heartbeats. Some hoped the object would do nothing, that it would glide past perihelion like any ordinary body, and that the world would wake up tomorrow unchanged. Others hoped it wouldn't, that it would deviate, even slightly, and force humanity to finally confront the reality many have sensed was coming. The sky would answer soon, and when it did, it wouldn't care about markets, institutions, or fear. It would simply reveal where the object is, and that position, whether shifted or still, will decide what story humanity wakes up to. For now, the night remains silent. The sun holds the object behind its light, shielding whatever happened in the dark. Across the world, instruments wait, analysts wait, governments wait. When 3i Atlas reappears, the truth will no longer belong to speculation. It will be written in its orbit, carved into the sky with the quiet certainty of something that does not need to explain itself. Whether it's natural or not, it has already done something extraordinary. It has forced humanity to listen to silence, to notice the patterns in what is missing, and to ask questions that can't be unasked. If it re-emerges on a new path, it will not be an announcement. It will be a quiet, undeniable fact, one that doesn't need language, only trajectory. And in that moment, the sky will feel different, heavier, closer. Until then, the world waits.